Hi there guys, Mr. Martin here again. Thank you so much for joining me onto a new topic for this video, and we're going to start looking at sleep, dreams and sleep disorders. Now this is the mandatory topic in higher psychology, meaning we need to know a lot about it. Chances are we're probably going to be getting an exam question on this one. So we're going to start by looking at the basics, the nature of sleep, and we're going to be looking in particular at the stages of sleep. So we're taking a scientific look inside the brain and seeing what's happening when there's not much happening. So let's dive straight in. The first question we might want to ask ourselves here is, well, what actually is sleep? The average person will spend 6 to 8 hours a day asleep, and that means it's about a third of their lives. So if you think you are asleep for a third of your life, it must be for something, right? It can't just be for nothing. So let's start off by defining sleep. In psychology, we would define sleep as a state of reduced consciousness, reduced activity, and reduced response. Reduced consciousness means you're not really aware of what's going on in the world around you. Reduced activity, you're normally lying down on your back, can't really move your muscles, not really doing much at all. And reduced response as well. If someone starts calling your name or shaking you to get your attention, it takes you that little bit longer to actually get back into the swing of things and thinking, oh, okay, I've got to do something here. So it's basically a reduced consciousness that's going through your body here. Good example of a circadian rhythm. And a circadian rhythm, there are a few of them. Body temperature might be another one, but sleep is the most well known. A circadian rhythm is something that varies over a 24-hour cycle. So, pending no major catastrophes, you probably have a normal sleep-wake cycle, which means you normally spend, roughly speaking, about 16 hours of your day awake and 8 hours of your day asleep. That would be an average sleep-wake cycle and a pretty average circadian rhythm. Lastly here, sleep changes throughout your life. Now that 8 hours, that's about right. Most people would probably get by on less than that. But the older you get, it seems to be the less sleep you actually need. Now when you guys are just now a teenager and you're thinking about, studying and things, you're probably getting by, going to bed, let's say 12, 1 a.m., something like that, waking up about 6 or 7 to go to school the next day. According to Wolfson and Kerskaden, that's nowhere near enough. What they actually find in this little study that they do is that the more sleep an adolescent gets, the higher their exam results are. Now they actually report that 7 hours and 20 minutes is the ideal amount, but the more you get, the better your exam results are. So you can say to your mother the next time she's like, oh, why are you sleeping in on a Saturday? What's wrong with you? Get out of bed and do some studying. You tell her from Mr. Martin, well, I'm actually making myself better by being asleep. Science, it proves it. How do we measure sleep inside the head? Well, normally what we do is something called an electroencephalogram. Quite a big word to say, so we would shorten that to EEG. And an electroencephalogram is normally used to measure sleep. It can also be used to measure consciousness as well. So you might see these things in, for example, coma patients or patients of stroke, but normally it's used in sleep studies. How does it work? Well, normally it's a few little electrodes that are placed on either side of your head, either temple, and it records the electrical activity of your brain. On the readout of the screen, this is what you get. It's just a series of waves. Now, to the naked eye, this looks pretty difficult to actually determine what on earth is going on here. Basically speaking, the more waves, the more kind of jaggy the image looks, the more awake the brain is. So if you're nice and awake, hopefully just now and listening to me, then you're going to have lots and lots of waves going up and down. When you go to sleep tonight, you're going to have less waves. That's roughly speaking how it works. So let's try and apply these two things together, sleep and the EEG, and see what we find. When you are drifting off to sleep, what first happens is you go through a series of stages that we collectively know as non-REM sleep. We'll talk about what REM is in a second, but non-REM sleep, I like to call it NREM, it's a nice way to say it, is characterized by this. When you are just drifting off, your brain looks pretty much the same as when it would be awake. Now, you've probably seen your parents, maybe yourself do this. If you're standing, or sitting rather, in front of the TV and you're gradually nodding off, you know that you are kind of half asleep and half awake. That's stage 1 of NREM. Stage 2 is when you're a little bit less responsive. If you are waking up at this time, then you might say, no, I wasn't falling asleep, I was absolutely fine, I was still conscious. But the fact is you were almost asleep. And what we see here are things called sleep spindles. These are random little kind of increases in activity in the brain. It's unclear what these are for. It might be to prevent you from waking up at this time, so it might actually speed up the sleep process. Stage 3 and stage 4 are collectively known as slow wave sleep, and you can understand why looking at this image. We've gone from having a really jagged image here, lots and lots of waves, to it gradually starting to slow down. Slow wave 1, which is stage 3 of NREM, is a much more deeper sleep. In this case, you are really kind of unconscious at this point. You're not fully asleep yet, but you're still going to be pretty groggy if someone wakes you up. By the time, however, you hit slow wave 2, that's stage 4 of NREM, then you have these things called delta waves. Delta waves are huge, big, sweeping waves that go up and down. Compare these ones to these one here in stage 1 and the awake stages. Delta waves means you are properly, absolutely dead to the world. Nobody is going to wake you up, at least not without a massive fight. If you are woken up at this stage, you're going to be really groggy and really, really confused. That leads us, however, into the 5th and very mysterious stage of sleep that we call REM. So we've gone here from being awake, stage 1, stage 2 of NREM, stage 3 and stage 4 of slow wave, and all of a sudden, well, but the brain's woken up again, hasn't it? That's your awake symbol. Well, no, you are fast asleep at this point, but it looks like, at least according to the EEG, as if you are awake. Now, at this point, you are no more awake than if you were in slow wave stage 2 or NREM stage 4, however you want to put it. But your brain is awake. What it's doing is dreaming. Now, most of the dreaming would happen here. You can occasionally get dreams that happen there as well. But basically in REM sleep, because your brain's active but your body's not, that's when you are dreaming. It's worth noting at this point, guys, that when you are in REM sleep, the rest of your body completely switches off. So even if you did wake up in REM sleep, you're going to find it very, very difficult, if not impossible, to actually move. We call that sleep paralysis. Let's look at a very quick key study in this area, guys. Dement and, that should say Kleitman, my apologies, I'll change that in post-edit. Dement and Kleitman, 1957, their study of REM sleep. Now, we know that REM sleep is where dreaming happens because of their influential work. Let's have a look at what they did here. What they do is they get 9 participants together. That's 7 males and 2 females. Worth noting that one of the 7 males is actually Nathaniel Kleinitman himself. So this is Kleitman in the study, getting ready, all dressed up in the EEG, ready to get to sleep. Now, when they were sleeping, their sleep progress was measured on an EEG, and as soon as they hit REM sleep, they were woken up. And they were asked if they were dreaming, and if so, what were they dreaming about, and how long do you think that it had lasted? What we find, reasonably straightforward. If they were woken up during REM sleep, the participants were much more likely to report that they were dreaming. As well as that, if they were woken up within about 5 minutes of entering REM sleep, they tended to report, well, I thought I was dreaming for about 5 minutes. If it was 15 minutes into REM sleep, they would say, well, I think that was about 15 minutes worth of a dream. Seems to tell us here that dreaming happens in real time, which is quite interesting. And as well as that, when you are REM sleeping, REM means rapid eye movement. So if you actually look at someone in REM sleep, their little eyes are moving up and down and left to right in all sorts of ways. It looks like they're kind of twitching, but they're not, they're asleep. When you are REM sleeping, your eye movements seem to link up to what you're dreaming about. So if your eyes are moving up and down and you wake the person up, they're saying, oh, I was just dreaming that I was climbing up a ladder, up and down, linked to the ladder perhaps. If their eyes are moving left to right, they might be watching a play or something like that, on a stage or on a screen, something like that. So it seems to be quite interesting that the eyes link up to what's happening inside the brain. Valuation of the study though, guys, you've already noticed by now, 9 participants, pretty useless, right? Very small sample. Artificial as well. These guys are getting woken up several times during the night. Normally, when you're sleeping from, let's say, 11 p.m. all the way through to 7 a.m. the next morning. You don't get constantly woken up. So this is really artificial. As well as that, it's in a lab. Are you going to be comfortable about that? Probably not. And as well as that, we know that adults and children seem to have different dreams and they dream at different times and about different things. This study was focused over much on adults. If we were to do the same thing with kids this time, would we get the same results? We're not so sure. So a pretty good study to start with, but ultimately a little bit flawed. That's a very, very brief introduction into the nature of sleep, guys. When we come back in our next video, we'll be looking at the next little bit of the nature of sleep, which is all about basically factors affecting sleep, things like drugs, caffeine, that kind of thing, and also what happens when we're sleep deprived as well. But here are the concepts you should learn for this little video. What sleep is, first of all. What a circadian rhythm is, secondly. The sleep-wake cycle, that's your 16 hours awake and 8 hours of sleep, roughly. What an EEG is. The different stages of sleep, that's the 4 stages. And then the delta waves in the last 2, slow wave sleep. Slow wave sleep, also known as NREM for the last 2 little bits there. REM sleep as well, that's when your brain thinks it's awake, but really it's fast asleep. And also those little sleep spindles as well. That happens, remember, in slow wave stage 2. So if you learn all those things, guys, you'll be absolutely fine moving forward into the next video on the slightly more difficult concepts involved in sleep psychology. That's it for today, guys. Thanks so much for joining me, and we'll see you again next time. Cheers!